All right, so notice I've changed it now. Got with replacement. What is the probability that both cards are spades?
If you do the replacement, do you have to have two decks?
No, just one deck. Okay, what is the probability both are spades? All right, so we got the probability that it's spade on the first and spade on the second. So we still, it didn't say and. Some of these and problems will say and in them, but this one didn't say and in them. But it is an and probability, isn't it? Spade on the first and spade on the second. Okay, well, and I'm not even going to write out the rest of it, but it's going to mean multiply two probabilities, right? I'm going to multiply the probability here times the probability here because it's and. Now, what's the probability that, what's the first probability that goes here? Well, it's probability that it's spade on the first. What's the probability that it's spade on the first? Same as we had a while ago. 13 out of 52. The second probability is the probability that it's spade on the second, given though that spade on the first occurred. Okay, so we drew a card and it was a spade. However, this one's with replacement. It goes right back in. So what is the probability that the spade is, the second is a spade?
13 out of 52.
It's 13 out of 52. See that? Why didn't it drop down here? Because it's with replacement. That was a big change, wasn't it? If this was without replacement, then these numbers go down. But with replacement, I drew the spade, but it went right back in. Okay? So it's back to 13 out of 52, which, like I said, if you multiply, you get 169 out of something. 2704? 2704, but that reduces way on down to 116, doesn't it? Reduce that down. Okay?
So how, the only way that we'll know the difference is that it will say that there is a replacement.
With replacement or without replacement. Yeah, that's a big change, isn't it? If you go with replacement, it's a little different. Now, tied in with that, let me talk about this. What we saw was this probability didn't change. I mean, it was spade here and spade here. Without replacement, this second one changed. With replacement, it didn't. In that case, what we have here is what's known as independent events. Two events are independent if the occurrence of one doesn't affect the probability of the other. Isn't that what happened here? I did draw a spade on the first, or I thought about it. If I think about drawing the spade on the first, that in no way affects the spade on the second, does it? It doesn't affect it because it's with replacement. Okay? So the occurrence of the spade on the first didn't affect the probability of the spade on the second. So that's what we're talking about, independent events. Now, what's significant about it is this. If A and B are independent, then the probability of A and B just simply equals the probability of A times the probability of B. Now, what's significant about that? You don't have to know anything about conditional probability here. This isn't a conditional probability, is it? So if A and B are independent, because the condition doesn't matter, yeah, you can just do the straightforward just probability A times probability of B. Okay? So that second one is not a conditional probability, like it has to be in the other scenarios. Okay? All right. But we'll talk more about independence things in a moment. Let me do another one with a couple more with the and. Do another example here. Let's say a jar contains 5 black, 4 white, and 8 red marbles. If 3 are drawn without replacement, what is the probability of drawing a black, red, and white in that order? What's the probability of drawing a black, red, and white in that order? Well, point of doing this one is, I'm doing the probability that it's black first and red second and white third, or some, however you want to write that. This is another and probability, isn't it? Okay. So, what does that mean? Well, I'm going to have to do 3 probabilities, right? And multiply them together. I'm going to do a probability here, then I'm going to do a probability here, and then I'm going to do a probability there. It's going to be 3 probabilities. Yeah, this and probability formula can be extended to 3 probabilities or 4 parts, 5 parts. It doesn't just have to be 2. But it is and so what do I do to my probabilities? I multiply. Okay, and means multiply. All right. So what's my first probability? First probability is black on the first. What's the probability that it's black on the first one? 5 out of how many? 17? 5 out of 17? I got 5 black, and then I've got 5, 4, and 2, 5, 4, and 8. That's 17. 5 out of 17. Okay? What's the second one? Well, the second one I'm doing the red, but I have to do it given the first occurred, right? So this is the probability given the first was black. So what about that? Well, we're drawing a black. We're saying we're given that the first was a black. So we drew it and it was a black. We didn't replace it. So what's the probability that it's red here? 8. There's 8 reds still because I drew a black. Out of how many though? Out of 16. Because I did draw a black, so 1 less marble is in there. 16. With me? Okay. The last one is the white one. So I'm going to do the probability this one's white, but what's happened? Well, I drew the black, and then I drew the red, right? So now this one's also, we're given, this one was the first one was black, but we're also given the second was red. So what does that mean? So I drew the first one was black, the second one it was red. So what's the probability now that it's white? Well, there's still 4 whites out of 15. Multiply those together. It'd be 160 out of something. 4,080. But that's going to reduce to what? 2 out of 51? Yeah, there's lots of nice cancellation there. Reduces by 8, I see. Reduces by 5. By 2.
That's not what that means.
What?
Oh. Where it says 25 and a U and then a half.
I don't know what that means. I don't know what that means. Okay. All right. All right, so now, if 3 are drawn with replacement, what is the probability all are black? Three drawn, all black. Well, and's not in there, but this is an and probability because it's black on the first, and black on the second, and black on the third. Right? This is an and probability. So I'm going to do 3 probabilities and multiply them together. Now, what's the probability that the first one's black? 5 out of 17. What's the probability the second one's black? Do I go down any? Not this time because, yeah, it's with replacement. So, yeah, I do say I'm given that the first was black, but I replaced it right back in, so I'm back to 5/17. Yeah, this one doesn't go down by any. And then the third is black. Be 5/17.